I just wanted to take a few minutes, talk a little bit about Nuvera, and also give you a perspective on our approach to hydrogen infrastructure solution. As you know, the auto companies are launching the fuel cell cars starting next year, and one of the big challenges is the infrastructure, and we have a novel approach to dealing with that, and I just wanted to share some other thoughts with you. Um, So Nuvera is a company based out of headquartered in Billerica, Massachusetts. It's been around formed in 2000. It's been around, and the teams have been working on fuel processing and fuel cells for a long time. We are an ISO certified company. There are about 130 people. We have a subsidiary, a wholly owned subsidiary in Milan, Italy, called Nuvera Italy, and they support our activities in Europe. Um, um, so if you look at the hydrogen value stream, from all the way from generation of hydrogen to the dispensing of hydrogen, Nuvera has very unique technologies that cover all the aspects of the value stream map. So we do on-site generation of hydrogen. So we take natural gas and water and we reform it on-site to make hydrogen. And then we have a purification technology called pressure swing absorption that purifies the hydrogen for fuel cell applications. And we also have compression technology that takes that hydrogen and compresses it to either 350 bar for bus applications or industrial mobility applications, or we can go all the way up to 700 bar for automotive. And then obviously we have a fuel cell also that takes that hydrogen at the compressed levels and converts that to power. So when you look at Nuvera is unique in having all of these technologies under the same organization. So if you look at our on-site solution, what we do is a process called steam methane reforming. This is something that's been around for a long time. I mean, most of the hydrogen is around the world is manufactured by using steam methane reforming. But the novelty we bring to the table is the ability to do that at an appliance level. So the best analogy I can convey to you is the same thing as the computer industry versus the hydrogen industry. If you look at computers, they have moved from mainframe computers to laptop computers, and now everything moves back to the cloud, right? So the same analogy can be applied to hydrogen, where you have large industrial plants that make hydrogen. We are trying to create the appliance, the laptop, which is a small device that you can put in your house or at a fueling station. We think the long-term solution for hydrogen is pipelines, which is an equivalent to the cloud. So you're going back again to the cloud, which would be the pipelines. But for the next few decades, we see on-site generation of hydrogen as a key enabler for the hydrogen infrastructure. So this device is basically taking natural gas and water and power and making hydrogen. Very high purity hydrogen and SAE quality hydrogen for use in automotive vehicles. So we are deploying this at many different markets, and I'll talk to you about the markets and our experience surrounding that. So the inside of the device is pretty simple. It's got 3 bays. The first bay is used to purify the natural gas and the water. The second bay is where you have a lot of the steam methane reforming that happens there. And the third bay is where we have the PSA, the pressure swing absorption system, which purifies the hydrogen to very high levels of purity. So it's a very simple product. We are deploying this at many locations. We can monitor the product remotely from many locations, and we provide a full service and support to the customers. So from a business point of view, our goal is to take this product and apply it in many different markets. So we have obviously the merchant hydrogen market, which has been around for a long time. That's hydrogen as a commodity. We sell this reformer systems to customers, the industrial gas customers. The same product is also used in industrial mobility, which is forklift trucks, range extenders for delivery trucks, or also now a new market, which is the refrigerated trucking, which is quite large in the United States. And the other market is obviously the transportation market, which is cars and buses and aerospace. So we have activity in all these areas. So this is, the forklift market is something that has accelerated quite a bit in the US. And this is the name of some of the companies that are actually using fuel cell forklifts. Most of these, we supply hydrogen to some of these customers, and by using an on-site solution. So this is an example of a customer in Riverside, California. What you're seeing here is a greenfield facility where there are about 100 fuel cell forklift trucks running inside the building, but outside the building, Nuvera has installed the hydrogen infrastructure for the customer. So this is a 100 kilogram a day site. It has got two reformer systems that make 50 kilograms each. So basically it's a greenfield installation. We go there, we deploy the site, and we deliver hydrogen to the customer inside the building. So this is a very unique solution, because the permitting time required to get this site is less than a few months. If you compare that to any other type of hydrogen infrastructure installation, it takes a much longer time to get a permit. This is another customer in Virginia Beach. So this is a brownfield site where a customer wanted to try and test a few fuel cells, right? They wanted to convert maybe 10 or 15 forklift trucks to fuel cells. So what we did was we started with one PowerTap product, which is 50 kilograms a day. If you look at it, the hydrogen infrastructure is 5 feet from the wall of the building. So it's from a permitting point of view, it's a very easy task in terms of being able to deploy the infrastructure. This whole site took us 3 months from start to end to get the installation done and the hydrogen dispensed to the customer. So now this customer has gone from using 50 kilograms a day to 100 kilograms a day. So we have just installed a second system and upgraded them to higher levels of hydrogen usage. So the product is very modular. So you can start with a certain amount and then increase as your demand increases. The other very interesting project that we are doing is use of fuel cells in refrigerated trucking. Okay, so in terms of hydrogen usage, a car will typically use about 0.5 kilograms of hydrogen per day. A forklift truck uses 2 kilograms of hydrogen per day. Okay, a refrigerated truck uses 8 kilograms of hydrogen per day. So if you're looking at hydrogen business, that is a very exciting business, because there are 300,000 refrigerated trailers right on the roads in the US at any given time. Okay, so if you're looking at the next 10 years in terms of hydrogen sales, the forklift market and the refrigerated trucking market are probably much larger than the automotive market. So that's an area where we are very interested in pursuing. So in this project, which is funded by the Department of Energy, we are working with Thermo King. Thermo King, as you know, is a dominant player in refrigerated trucking. We are putting together a fuel cell system that will be tested with customers like Cisco and HEB towards the end of this year. So this is a very exciting market for Nuvera. So coming to the last area for the hydrogen discussion is the hydrogen infrastructure for automotive use. As you know, the California ZEV mandate requires the introduction of fuel cell vehicles for companies that sell more than 20,000 cars in the state. The unique thing in the US is that a number of states can either adopt the California regulations or they can go to the federal regulations. And today, a number of states in the Northeast, I believe it's about 13 states in the Northeast, have adopted the California regulations. So what that means is that car companies not only have to introduce cars in California, but they also have to do it in the Northeast. So we are expecting that will happen over the next 3 or 4 years. And the unique position that Nuvera has is that in terms of answering the chicken and egg question, I think we have an approach that answers that. So typically, there are 3 questions that matter when we come to talk about chicken and egg. One is, do you have the retail footprint to dispense the hydrogen? So because customers will not want to drive out of their way to get the hydrogen, they want to be able to go to a retail station and get the hydrogen. That's number one. The second thing is, if you have a retail footprint, do you have a product that fits into that retail footprint? because these foot retail locations are pretty small, point 2, point 3 acres. So you need to be able to put the product in the retail footprint. And the last thing is it cost effective? Do you have a cost effective solution? Because customers are not going to pay more for the car, and they're not going to pay more for the fuel. So there's got to be a driver for them to convert to hydrogen, and the cost has to be competitive. So what Nuvera brings to the table is the ability to answer these three questions. Nuvera is a wholly owned subsidiary of the Hess Corporation. And if you look at the states where the ZEV mandate is active, all along the East Coast, Hess has got about 1,400 retail stations, all owned by the company, or most of them are owned by the company. So we have, through our relationship with Hess, access to the retail footprint. So in the ZEV states, there are about 500 stations that we can work with Hess to create the infrastructure. So that answers question number one. Do you have access to the retail footprint? And I think Nuvera does have access to the retail footprint. So we've been working with a number of companies in the Northeast, with National Renewable Energy Lab, trying to define what would be the approach of hydrogen infrastructure to the Northeast. We are looking at 3 regional clusters: Boston, Hartford, and New York. This will be the main regions where we would launch the infrastructure, and then there will be corridors that would come beyond that. So this will be the 3 main regions for us to start the hydrogen infrastructure rollout. If you look at typical modes of hydrogen delivery that's happening today, you have that is done by most companies. You have very large industrial plants where hydrogen is made through steam methane reforming. Then you basically liquefy that, okay, and then you transport that hydrogen to a station where you have storage for liquid. Then you have vaporizers. Then you compress that gas, you store it, and then you dispense it. So that's your conventional mode of hydrogen delivery today. And if you look at the footprint of this infrastructure, you can't imagine putting this infrastructure in the middle of Manhattan or in the middle of Boston. There's no way you will get a permit to do that. So our solution is more looking at on-site generation of hydrogen. And our solution is this. So it's an on-site device that takes natural gas, water, and power and delivers compressed hydrogen at 700 bar. So that's the vision that we have, which we are going to be able to deploy starting 2015. So that's the mission of the company in the infrastructure side. We're very excited about it. The one thing that I wanted to mention is our compression technology. If you look at hydrogen infrastructure today, and you talk to anybody who's using the infrastructure, they will all say that the compressor is the weakest link in the value chain, and the most unreliable part of the system is the compressor. What Nuvera, with its experience in fuel cells and electrochemistry, what we are moving forward with is an electrochemical compressor. It's a compressor that uses electrochemical technologies to go from very low pressures up to 700 bar. So the advantages of that, and what you're looking at is the device standing next to the person, is a 50 kilogram a day electrochemical compressor. Okay? It doesn't look like a compressor, but it does compress hydrogen. So the advantages of this device is obviously the footprint is really small. Okay? It's quiet. There are no moving parts, so it's extremely quiet. You can't have a mechanical compressor in a retail station in the middle of the city with all the noise that the compressors make and the footprint that they take. So we have, this compressor is extremely quiet because there are no moving parts in it. The most significant part of this compressor, which I think a lot of the auto companies will like, is it works on the principle of electrochemistry. So the hydrogen is going through a membrane. So in the process of compression, you're also purifying the gas. So there's no way you will have contaminated hydrogen going into your fuel cell car, which is one of the biggest challenges today of contamination at the gas stations. So we are very excited about this technology. It's showing great results in our lab. and we expect to deploy them in the field starting next year. And the last question is, what is the cost of hydrogen, right? So we talked about the retail footprint, we talked about the size of the product, and the last thing is, what are the costs of the hydrogen? We feel very confident that we should be able to deploy hydrogen infrastructure at a cost that is meaningful from a business point of view. Today, if you look at the selling price of hydrogen, or the targeted selling price of hydrogen in the US, at $10 a kilogram is a number that a lot of companies use, that dispensing hydrogen at $10 a kilogram for the automotive industry. We feel confident that with our solution, that Nuvera would actually be able to make a decent margin to have a business surrounding that. So I'd like to end with that note, saying that the hydrogen infrastructure, when it comes to the hydrogen infrastructure, I think we have a viable solution for it, and we look forward to working with the companies in Europe and also the automotive companies around the world to get it done. Well, thank you.
Thank you very much. This is your applause.
Yeah.
Thank you very much for this interesting presentation. And for your sudden resolve just coming here on stage. So certainly it would be nice. Thank you for this again. Yeah. So are here any questions around now? So, yeah.
Very good presentation, and thanks. And you shared very concrete plans, look like, what you are going to do next year. Do you foresee, demand building up for you when you're ready with the stations? I mean, people still have to buy these cars after they're introduced.
Yeah. So I think obviously a lot of the drivers behind the demand is the ZEV mandate, but I think most companies are looking beyond compliance, and we feel that the demand's going to come, and the fuel cell vehicles are going to perform equal to or better than other technologies that are there, and as a result, consumers will be wanting to buy that. I use the term, instead of chicken and egg, I'd like the industry to start using the term synchronized swimming, which is that the infrastructure people and the auto companies have to go synchronized and go together, because it's a shared risk and a shared reward situation. So I think that's the kind of discussions that we are engaged in.